Today, we are doing a deep dive into the convergence of two, well, really powerful technologies: artificial intelligence and digital twins.
hmm
And they are completely reshaping how logistics managers think about, moving goods around the globe. This isn't just about small efficiency gains.
No, not at all. This is about building what you could call a virtual supply chain.
A virtual supply chain that's designed for what? Extreme foresight.
Foresight is the absolute critical element. We're moving far beyond the old ways of forecasting.
Right.
I mean, our mission today is really get into the mechanics of this. How does integrating AI with a digital twin let a business predict major supply chain disruptions? Not just days, but weeks ahead of time.
Weeks of warning time.
Yeah.
That's transformative. And it's why this is such a vital topic for anyone trying to understand modern business resilience.
It is.
So let's unpack the core mechanics, look at some real applications, logistics, manufacturing, retail, and then, talk about the real barriers companies are facing.
Sounds good.
Let's start with the foundation then, the digital twin, or DT.
The DT is absolutely the starting block. You can't do any of this without it. It's a dynamic, virtual replica of a physical system,
In this case, the entire supply chain.
the entire supply chain.
Yeah.
You should think of it less like a static map and more like a living digital mirror that reflects every single process in real time.
So inventory levels, factory output.
Everything. Transportation routes, even down to the performance of a single machine on a factory floor.
Okay, so for that to work, it needs a constant stream of real-time data, right? It's no good if it's based on yesterday's numbers.
Precisely. That's the key. The DT is always being updated. It's just sucking in these enormous volumes of data. It tracks everything from where your assets are to these critical external things,
Like what?
like backlogs at a container port or shifts in labor availability or even, sudden local regulatory changes.
And the power of that for a manager isn't just seeing what's happening now, but it's about testing the future, isn't it?
Absolutely. The unique utility of the DT is that simulation power. Managers can run basically unlimited what-if scenarios inside this virtual environment.
Okay.
So they can model the impact of, say, a 3-day port closure.
Or a sudden 20% spike in demand for one product.
Exactly. They can see the ripple effects of that decision before they commit any real-world resources. They're essentially avoiding the disruption before it even begins.
But a virtual replica, I mean, no matter how detailed it is, it's just a huge pile of data unless something is actively making sense of it, right?
Right.
Connecting all those millions of dots.
Right.
And I assume that's where the AI comes in.
That is where the brain power comes in, yes. The DT creates this incredibly complex data environment, and then the AI is what processes, analyzes, and interprets that massive volume of information.
And we're not just talking about simple analytics like what happened last week.
No. We are focused on machine learning algorithms that perform predictive and prescriptive analytics.
Okay, let's nail that difference down. Predictive tells you what might happen. What's prescriptive?
Prescriptive is the highest value. It doesn't just predict a problem is coming. It actually suggests the best corrective action to solve it.
Wow. Okay, so an example.
Sure. Let's say the AI predicts a material shortage is going to hit in 4 weeks. The prescriptive function would instantly suggest something like reroute 10% of shipments through port B and start a secondary supplier contract now.
So it's giving you the answers, not just the warnings.
It's giving you the answers.
Okay, this brings us to the core synergy here. The old methods, they relied on historical data. We could call it reactive management. What is it about this integrated system that lets it see weeks into the future?
The critical shift is in what we call dependency mapping. Now, see, traditional forecasting just looks at simple time series data, what were sales like in the fourth quarter last year.
Right.
This integrated system, it uses advanced graph analysis to map these non-obvious correlations and really complex dependencies across the entire chain.
Give me an example of a non-obvious correlation, something that buys you those precious weeks of time.
Okay, so a human manager might see a minor price fluctuation in a specific raw chemical that's sourced from Southeast Asia. They might just, file it away.
Mm-hmm.
The AI, though, operating inside the DT, it immediately correlates that tiny price change with 2 other variables. One, a 2-month historical link between that fluctuation and, say, upcoming labor union negotiations.
I see.
And 2, a resulting projected decrease in available shipping container space 3 weeks later.
So it's seeing the first tiny tremor and connecting it to a massive earthquake down the line.
That's exactly. It identifies these subtle leading indicators that no human team could ever track manually across, dozens of suppliers, and hundreds of routes.
And this ability to spot that systemic ripple effect weeks out, that's the strategic advantage.
That's everything. It lets companies shift from a panic-based reaction to a proactive, measured optimization. You're adjusting your sales while the storm is still way out on the horizon.
That benefit is crystal clear. Let's see this in action, then. Let's start with the huge logistics sector, which, lives and dies by efficiency. How are companies like FedEx or DHL using this now?
For the big logistics carriers, the application is just massive scale optimization and resilience testing. They use the DT to simulate their entire fleet operation under all kinds of stress tests.
So not just one truck, but the whole network.
The whole network. Everything from managing specific delivery delays caused by, say, localized flooding, to optimizing thousands of individual vehicle routes at the same time based on predictive traffic models.
And this does more than just save gas, I assume.
Oh, absolutely. It maximizes fuel efficiency, yes. But crucially, it prevents one single delayed package from cascading into a network-wide failure.
So it's turning this massive complexity into optimized simplicity. Okay, let's move to the physical production side. How does this look in manufacturing?
Well, manufacturing uses this technology to synchronize their demand planning with actual physical production. They don't just use the DT to see what inventory they have now.
They're looking ahead.
They're using the AI to project future inventory needs based on predicted shifts in demand. The AI is actively managing raw material ordering and the production sequence to prevent two extremely expensive mistakes.
Which are?
Critical stockouts, which just stop production cold, and costly overstocking, which ties up huge amounts of capital.
So instead of ordering based on last month's production rate, they're ordering based on what the AI predicts they'll need 2 months from now, and it's factoring in all the supplier lead times.
Precisely. And for the retail sector, which deals with so much volatility, this is just instrumental. Retailers are using the DT to model consumer behavior in real time. They often combine their internal sales data with external social trend data.
So they can predict those unpredictable surges, like a sudden TikTok trend causing a run on a specific product.
That's a perfect example. The AI identifies when and where those demand surges are likely to happen, which lets retailers optimize where they place their physical inventory before the customer even clicks buy.
That has to streamline the customer experience.
Yeah. It streamlines it significantly, it ensures better fulfillment rates, and it drastically cuts the cost of that, emergency expedited shipping you always see during peak seasons.
This all sounds like a completely automated system of perfection, but we know implementing this kind of sophisticated tech is not easy. It's not instantaneous.
No.
What are the big obstacles right now preventing everyone from just adopting this?
There are three pretty significant barriers. The first one is just the immense cost of implementation.
Right.
This isn't just about buying some software. It's about engineering a highly accurate DT. That means integrating advanced sensors into every step of the supply chain, often, retrofitting old IT systems to feed data in real time. That requires massive initial capital.
Okay, that makes sense. And then once you build a system, you need the right people to run the brain. That's the second hurdle.
Absolutely. There is a huge global demand for the kind of specialized people who can manage this complexity. You need this rare blend of deep data science expertise. You have to understand machine learning, and you have to combine that with extensive domain expertise in global logistics.
And that talent is hard to find.
Very hard to find and very expensive to keep.
And finally, you have the sheer volume of sensitive, real-time data being processed. That's got to raise some huge concerns.
Data integrity and security are they're paramount. These systems are tracking the movement and location of billions of dollars worth of assets.
Not to mention proprietary production info.
All of it, in real time. If that data environment gets compromised, the competitive exposure is just enormous. And beyond that, the operational reliance on the DT means that if the data is faulty or biased,
The whole system makes bad decisions.
poor, sometimes catastrophic decisions. The critical element here is the trust that you place in the algorithm's output.
Trust is a fascinating angle. Because even if you solve for the cost and the talent, you still have to trust a system that is often operating without a human override.
Right.
But despite these barriers, we expect things to evolve. Where is this technology headed in the next, say, 5 to 10 years?
Well, as we've seen with other technologies, costs tend to fall over time and accessibility increases. I think we'll see more modular DT solutions become available.
Which would lower the barrier to entry for smaller companies.
Exactly, for smaller or more regional businesses.
And the ultimate vision, if we're predicting problems weeks out right now.
The ultimate vision is fully autonomous supply chains.
Wow.
This is a state where AI-powered systems manage, well, virtually every aspect of logistics, from predicting raw material needs and negotiating procurement, to managing manufacturing and optimizing distribution.
All with?
All with instantaneous self-correction and optimization. It would require minimal, if any, direct human intervention.
That paints a really powerful picture of operational resilience and efficiency. I think the key takeaway here is that integrating digital twins and AI, it moves businesses from being reactive data consumers to being proactive, strategic decision makers. It's about not just seeing the present state of your operations, but effectively peering into their future.
And that transition to full autonomy, a self-driving, self-optimizing supply chain, is profound. It fundamentally changes the entire nature of logistics management. We've talked about how these systems are so good at predicting disruptions based on historical data they were trained on.
Right, the things they've seen before.
But this raises a really important question for you to think about. If AI handles every aspect of logistics, ensuring peak efficiency, what is the necessary role for human oversight when the system encounters a truly novel, unpredictable disruption, a genuine black swan event that was completely absent from its training data? In a system that's designed to eliminate human error, what is the irreplaceable value that a human brings when chaos requires ingenuity and not just optimization?